Hello, testing for Adam's stream. Hello, testing for Adam's stream. Hello, testing for Adam's stream. Hi guys, thank you so much for coming. We'll start in a bit. Let's just wait for a few more people. Uh, we're looking at 7:35. Okay, game. I think the stream is up na, so we don't have to wait for that many more people. And yeah, yun lang. Since tayo lang naman. Welcome guys. Thank you for coming. We could not find a tutor again, so you are stuck with me again. So yeah, let's do this. As per usual, make sure that you have a copy of Samplex B. So I will leave it at the side in case you don't. Pero ideally nga, sundan nyo while we answer it together. Or compare it with the with the initial answers na you guys got. Okay, so we can start. The first caveat na I want to make is, I think for WF sections, wala pa kayong linear transformation. Tama ba? So, that's tomorrow pa ata. Diagonalization pa yung last na discuss. So what I'm gonna do to make sure na as many people, I guess, benefit from this is, any item that involves linear transformations, I will skip muna. And then I'll just put it at the end for the circular sections that have covered it na. Okay, so I think that's fair naman. So in that case, we will be starting with number 2. So number 2 gives us a matrix and then asks us for a to the 8th. So this is an example of matrix exponentiation. So what we have to remember in matrix exponentiation is the base formula for this is basically my pen is not working. Ayan. A to the k is equal to c to the negative 1 times c to the negative, c times d times c to the negative 1. So the objective here, given that we are given matrix A, is to find what matrix D and C are. So matrix C and C inverse is basically it's basically the matrix containing all the eigenvectors, and then matrix D is a matrix containing all the eigenvalues in diagonal form. This is a bit abstract, so what I'm going to do is just jump straight into it. So, yung first thing na gagawin natin, given that, is we need to, 1, test for diagonality. And then, if it is diagonalizable, you want to find the eigenvectors and values. Okay, so we can do that at the same time. We just have to check that a matrix of an n-order matrix, so n by n, is diagonalizable if it has n number of unique eigenvalues. So we can just effectively look for the eigenvectors and eigenvalues. And if we get a distinct amount, then it's diagonalizable. So you can just do this at the same time. So let's use the equation for let's use the characteristic equation, or the equation with the characteristic polynomial, to find the eigenvalues. So it's effectively in this form. So what this means is, now we just copy our matrix A, negative 1, 2, negative 1, 0, 1, negative 1, 0, 0, 2. And then minus lambda 1, 0, 0. Oh, shit, sorry. Equals 0. Yung determinant of the whole thing. So the determinant of the whole thing is equal to 0. So now this just becomes negative 1 minus lambda 2, negative 1, 0, 1 minus lambda, negative 1, 0, 0, 2 minus lambda. So we're gonna look for the determinant of this equal to 0. Hopefully gets pa naman so far. I skipped a few steps na. So minultiply ko na yung lambda with with the whole identity matrix. So kaya siya along the diagonal lang may minus lambda. I hope that makes sense. So here we're trying to find the determinant. The nice thing about the question given is it actually makes it super easy for us to find kasi this is recall from LE1 upper triangular, which means na we can just get the determinant by multiplying along the principal diagonal. So the determinant is just negative 1 minus lambda, 1 minus lambda, 2 minus lambda is equal to 0, which will yield three values. So the first, so it will yield us three values, which are negative 1, 1, and 2. So these are the possible values for lambda. To check lang, these are three distinct eigenvalues, and therefore, let's just do the formal solution para masanay tayo during the LE. Since there are three distinct eigenvalues, matrix A is diagonalizable. Okay, so now we can proceed to doing the full method for diagonalization. So now we have our we have now our eigenvalues. Now we can find eigenvectors. So it's just a matter of plugging in the eigenvalues that we found into the function and then multiplying it by x such that you get 0. So it's basically just a modified times x equals 0. Modified being na-modify siya based on whatever the value of lambda is. So let's just do that one by one. So for lambda equals negative 1, we just plug this in. So this becomes 0 to negative 1, 0 to negative 1, 0, 0, 3. Then just multiplied by the elements of the eigenvector. So this is the eigenvector. Ito yung hinahanapan natin ng values. I guess small observation lang, personal observation. These will usually be relative to each other. So wag kayong mapanic if you can't find a specific value for it. In the vast majority of cases, at least the problems na we have been given, they do not have a specific value. Usually some will be in terms of another. So don't panic if ever mangyari yun. Anyway, from R3, we can deduce na x3 is equal to 0. So that's good na. For R2, we can deduce na 2x2 minus 1x3, which is just 0, is equal to 0. Yeah, tama. And then, we can also deduce na okay, so those are the two. And then, from observation, we can see na all the columns in all the elements of column 1 are 0. So whatever row gagamitin mo, x1, whatever the value of x1 is, so diba x1, i-multiply mo dito. So let's say you're multiplying this by this. Mag-0 yung x1 kahit ano. Same thing here, and then same thing here. Kasi 0 yung elements ng first column. What this suggests is na from R1, from any of them actually, na x sub 1 is basically any number k such that k is a member of the set containing real numbers. All that like fancy jargon just to say na k can be whatever number. So, ibig lang sabihin k can be whatever number. So now that we have this, we can now create our eigenvector. So we know na x2 and x3 are 0. And then, we know na x sub 1 can be k for any real number. And then, just to formalize that, we can bring out k 1, 0, 0 for all for all k member of the real set containing real numbers, blah blah blah. So, yeah, that's our first eigenvector. Now let's find our second and third. I'll just move up here a bit. Yeah. So now we can find our second one, which is for para hindi confusing for people looking back. Yan. For lambda equals 1 naman. Same thing, just plug it in. This is negative 2, 2, 1, 0, 0, negative 1, 0, 0, 1. If ever magkamali pala ako sa arithmetic, just please call me out. Medyo had to cram this din. Pero yeah, whatever. Yan. So, now we have this. Based on, so saan to nanggaling? We plugged in lambda equals 1 to this. So we plugged in lambda equals 1 to there. And then we got this. So now we can also just equate this to 0. So again, staying to our original form. Ito. And so, yeah. So since naka row echelon form na siya, we can just go straight into it. We know na x sub 3 is equal to 0 kasi multiplying this by this. So this is information from row 3. We know na this has to be 0 kasi it's 1 dito, diba? So automatic na yan. Same thing here. We don't get much information from row 2. So we can now go straight to row 1. Since row 2, we don't get any new information. From row 1 naman, we know na negative 2x1 plus 2x2 is equal to 0. Skinip na natin to kasi we know na x3 is 0. So, what that means is we can move stuff around. 2x2 is equal to 2x1, which suggests na x2 is equal to x1. So, now we let x1 equals k such that it is just a member of the set containing real numbers. And then, what that means is na, ulit, x1 can be any real number. So that's the first thing. So this is just like this. And then the second thing we know is that x1 is always equal to x2. So just 1 equal to 1. Again, this can be any number, technically. As long as they are the same. As long as they're equal, sorry. And then, but for general convention, ito lang yung, it makes the most sense to just make this 1 kasi multiply siya by k. And then, we know that x sub 3 is 0. So that's the second eigenvector. So now let's move on to the last one. Let's substitute for lambda equals 2 naman. For lambda equals 2, we get, yeah. Oh, someone unmuted. Is everything good so far? Okay, I will assume that this by accident.
Hello. Sorry, I only spotted it now. But Miko chatted pala na hindi ba negative 1 sa x13? Like the element row 1,
That-
column 3.
X1.
What?
Which part?
Yes.
For x row 1, column 3, dapat
Okay.
negative 1 daw.
Sorry, what?
Which
Okay.
one of the three? Which one of the three? So lambda equals negative 1.
Okay, we're not switching.
What?
Okay. 1 pa. Yeah.
What is happening? It's Jerome. Okay, Jerome, you are unmuted.
Oh, sorry.
It's all good. Sorry, Trey, what were you saying? Or was that Trey? I don't know who unmuted and pointed out something.
I'm not sure kasi which matrix Miko pointed out, but he just chatted 3 minutes ago na.
It's for lambda equals 1. I think
Lambda equals 1.
yeah, x1 3.
Yan. Ito. X1.
Row 1, column 3.
Yan, ito.
Yeah.
You're right. Yeah, pero
It won't matter naman, no?
luckily it doesn't. But yeah, just for correctness sake, ito, -1. So, doesn't change anything kasi we know na x of 3 is 0. So, luckily it did not undo what we have been doing for the last 3 minutes. Thankfully. Pero I'm pretty sure na -5 na yan kaya. Sorry, recorded pala to. Sorry. Anyway, let's go back. This is lambda equals 2. So, I just plugged everything in. This is -1. Thank you very much. Yeah, it's -1. So, just double checking. Nawala ulit. Arithmetic errors. I think this should be good. Okay. So, same thing. We just multiply it. Make sure we get the zero matrix. Or the zero vector, sorry. Tapos, same thing dito. Except, wala na tayong info from the third row because it's all zeros. So, we start from the second row. So, no info here. We start here. What we get from this is that negative x2 minus x3 is equal to 0. Which implies na negative x3 is equal to x2. So, that's our first piece of information. The second piece of information we get is negative 3x sub 1 plus 2x2 minus 1x3 equal to 0. So, let's do a bit of substitution para magawa natin siya in terms of two variables. So, it's a bit easier. Let's use this here. So, since this will be true naman everywhere, we can do that. And what we can do here is make it such that let's just replace x3, turn it into x2. So, magiging 3 x sub 1 plus 2 x sub 2 plus 1 x sub 2. I hope that makes sense. So, we just use this property, this information that we got. We use that to convert this negative x sub 3 into positive x sub 2 since they have that kind of relationship na, based on this. So then, continuing on, magkakaroon tayo ng 3x sub 2 equals 3x sub 1. So, ibig sabihin yan na x sub 2 is equal to x sub 1. And then, since now we know all of the parang relationships between each other, we can now proceed to creating the eigenvector. So, again, we let by convention lang x sub 1. You can start anywhere. It's completely fine. So, we're doing the same thing lang. 1k. Okay. So, okay. So this is x sub 1 because it's just k, diba? X sub 2 naman, we know it's equal to x sub 1. So we can also put 1 here. Paano to? We can just indirectly put them together. If x sub 3 is equal to, negative x sub 3 is equal to x sub 2, and then x sub 2 is equal to x sub 1, transitive property ata. Basta one of the early algebra properties. Yeah, so that's -1 because that's how they're related to each other. So yeah, taking note lang. Wait, I should have taken note of this earlier. So now we have the three values being k sub 1, k sub 2, k sub 3. And then, forgot to note the eigenvalues there. -1, 1, 2. Okay, so now we can use this to find C and D. So C is basically all of the eigenvectors put together in one matrix, and then D is the one that's the eigenvalues in diagonal form. So we can now put this together. So let's just do it in the order that we found it. So this is now 1, 0, 0, 1, 1, 0, 1, 1, negative 1. Which you will see later is quite convenient actually. And then D is equal to negative 1, 0, 0, 0, 1, 0, 0, 0, 2. Yan. Okay, this is a bit of a big jump, so please do interrupt if any part of that is unclear. But effectively, what we just did is took all the vectors, all the eigenvectors, the base form of it, so removing k na, into the matrix C, and then yung eigenvalues naman, we put it in diagonal form sa matrix D. So now we can perform the operation asked from us. So this is a to the 8th. So recall lang the equation we laid out kanina, which is C, D raised to 8, and then C inverse. The last thing we have to look for pala, before this, sorry, is C inverse. And we can do that using a method from LE1. So we start off with, we augment the matrix that we want to invert with the identity matrix. And then we convert this into identity, and whatever shows up on the right side will be the inverted version. So it's a slight shortcut ko na because this is like row operations lang. So R1 prime is equal to R1 minus R2, and then we can just hit all the birds with one stone or whatever. R2 prime is equal to R2 plus R3, and then R3 prime is equal to by convention, dapat negative 1 times R3. Ayan. Doing this all together. Let's start first with R1 prime. So R1 prime is 1 minus 0, 1 minus 1 is 0, 1 minus 1 is 0, 1 minus 0 is 1, 0 minus 1 is negative 1, 0 minus 0 is 0. R2 prime naman, R2 plus R3, 0 plus 0, 0, 1 plus 0 is 1, 1 plus negative 1 is 0, 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1. And then last naman, negate lang yung whole row. So that should be good. Ayan. So now we have found C inverse. So now, for real this time, we're now able to perform this operation because we have everything we need. Okay, I'll put it here. Yeah. Alright, so now let's just copy everything. Sorry, tinatamad na ako low-key. So, wow. C times D to the 8th times, wala pang space. Okay, wait lang. Yan, okay. So, effectively, let's just see this. So C times D to the 8th times C inverse. So, just to make it, I guess, simpler, let's first start by exponentiating the whole thing. I'll just show why it works. Now you can do this quickly. So, let's just take a 2 by 2 matrix for demonstration. Na diagonal form din. if you square this, di ba ibig sabihin lang yan, A0, 0B times A0, 0B. You're just doing this. But if you notice, you're multiplying this times this. So magiging A squared. Multiplying this and this, you get 0. Multiplying this and this, you get 0. And then multiplying this and this, you get B squared. So actually, when you multiply a diagonal, when you exponentiate a diagonal matrix, you just get the individual, parang pwede mong i-distribute sort of yung exponent. So that's why we prefer this method to just manually exponentiating. Kasi otherwise, sobrang hirap niya gawin. I'll keep that there for future reference na lang. Okay. So, doing that, we get negative 1 to the 8th is negative 1 to the 8th is, well, negative 1 to the 8th is 1. 1 to the 8th is 1. 2 to the 8th is 256. And then we can just do that. Copy everything. Okay. Question. Alin yung una yung multiply? Well, the answer technically is kahit saan, because matrix multiplication is associative. So we can do this first, or we can do this first. Because I like doing it from left to right, and I'm the one with the board. We will do the last two first. Okay. So, yan. Let's just multiply that. So, this times this is just 1. And then this times this is just 0. This times this is just 0. Second, wait, I should stop saying this. I'll specify. Second column times first row is negative 1. Wait, sorry. Dueling ako. 0. Yeah, negative 1. And then second column times second row is 1. Second row times second column times third row is 0. Third column times first row is 0. Third column times second row is 1. Third column times second row is 256. Negative 256. So, vibes. Alright. Now, we just have to multiply it by this. 1, 1, 1, 0, 1, 1, 0, 0, negative 1. So, repeat the same process. First column, first row. First column, first row is 1. First column, second row is 0. First column, third row is 0. Second column, first row is 0 because it's negative 1. Negative 1 times 1, negative 1. 1 times 1 is 1. And then negative 1 plus 1 is 0. Second column times second row is negative, second column times second row is 1. Dot pala yan. I almost confused myself. And then second column times third row is just 0. This is where medyo malaki na yung numbers. Third column times first row is negative 255. So positive 1 times negative 250 minus 256. Third column times second row is negative 255 as well. And then third column times third row is just 256. Ayan, so that's the final answer. So first I want to verify if there are no questions, if this makes sense. If somebody chatted, please people who can turn their mics on, let me know. Pero I'm assuming wala, so we can just continue. Okay, vibes. Third question. There's actually a lot of given in this third question. Find A, which is made out of three vectors, v1, v2, and v3, such that, and then lots of clues. So what I'm gonna do is just go through the clues one by one, or the givens one by one, and then we'll try to extrapolate as much information from one individually, and then we'll move on to the next piece of information until we can piece it together. So let's start with one. Let's start with A pala. I'll just name it by letter para madali. So this is actually doesn't give us much information, because if x1, x2, x3 is equal to 0, edi whatever value for v1, v2, v3 doesn't matter. So we actually don't get any info out of A. Out of B, we get 1. So it says na v1 dot e2 is equal to 0. Note na lang, I also had to look this up because this was not taught in class. E2 is just the standard vector for the y-axis. So ganito siya. I think you guys know this better as j hat. So yeah. So now we can proceed. So v1 times. So this is v1. We don't know pa what's inside. So let's label v11, v12, v13. Dot product 0, 1, 0 is equal to 0. Okay. So convention lang ng dot product. Let's just do the convention. So ita-transpose natin yung una, and then we apply matrix multiplication. Yan, 0, 1, 0. So we know that 0 times v11 will be 0, and the same case is true for v13. So again, we are stuck with the dead end. We cannot narrow down the values for v11 and v13. But we do know na v12 is v12 equal to 0. And the reason for that is yan na lang matitira when you multiply them together. So we now know na v12 is 0. So let's just keep that in the holding area this time para di tayo mawala. So I'll add on to this as we go along. So now we have info for v12. We know it's 0. Okay. Yeah. So that's for the second piece of info. For C naman, v2 times the image of B is equal to 0. Nakaturo lang nito. The image is basically okay. I have to explain this for the Nasty kids pala. Kasi this is kanina lang. The image is basically just the span of the bases. So in a way, parang it's just the column space. From how I understand it, it's very, very similar to, if not in most cases, equal to the column space. Do not quote me on this though, kasi this is just based on my understanding from kanina. But I will work with that because it matches with the answer key naman. So okay. Okay. So wait, let me just pull that up. Yeah. So let's take V2, V21, V22, V23 times the image of B. Okay, so medyo mahaba to. So C1, okay, image of B. This is B. So if you look at it, B is technically technically independent kasi you can't, wait, let me just make sure I'm right. Okay, actually it's not. Pero you can just take the column, you can just take the like full column space of this C2 500 plus C3. Since the third column is technically not independent because you can perform, what can you perform? Actually, yeah. You can perform 2C2 minus C1 to get C3. So 5 times 2 minus 4 is 6. So it is not part of the basis. So you can span the whole column with just this. And actually, same is true naman for 5. You can just take 5/4 of 4 so you can scale it. So it just brings down na ito lang yung independent. So this is what spans the space na. So this is basically the image. So we are left with, let's transpose it na agad. I'll just do multiple steps at the same time. V22, V33, V21, 22, 23. Yan. Times C14, 0, 0. Same thing as before, we don't get a lot of information from multiplying by 0. That can just mean any number. But what we do get as information is na V21 is actually equal to 0. So let's just add that here. Oops. Yeah. So that's what you get from C. From D naman is just given, so we don't really learn anything. Next naman is E tells us na V3 is orthogonal. It's orthogonal to the span of the following vectors. So, what does it mean first for it to be orthogonal to the span? I know that's like stacking concepts, pero recall lang, I'm not sure. Recall lang na most all matrices or all spaces can be defined by its basis. Or it can be defined by what spans it, right? So if we can find the basis or which of these vectors contribute to the basis, then we can just also conclude na it also basically follows na it's just orthogonal to that space. So to compare it, we just have to take the individual vectors of the basis. So if it's orthogonal to the space, if it's orthogonal to the basis, then it's orthogonal to the space. I hope that makes sense. I think I did not explain that in the best way, pero yeah, I hope that makes sense. Same thing here. Let's take the rightmost as the arbitrary starting point. We can achieve this by doing scalar multiplication. So let's just arbitrarily label this A1, A2, and A3. 2A1 is just equal to A2, so it's not included anymore. And then, so it's not included anymore. And then, same thing sa, with this naman. I think it's included. So, yeah, it's included. So now, we can take the space that this spans. So, basically, the span of this is just C1, the space this spans, the basis. So yung basis, ginagamit siya to span the space, diba? And it's just of this form. Yeah. Okay. So now, we just have to test na this is orthogonal to the whole space. And again, we can define the space in these terms. And therefore, we can just make sure it's orthogonal to the whole space by defining the space as like, I guess, one vector. And we can do that. I'll move it. Okay, wait. Pilitan ko na lang yung previous. Yeah. It's gonna look awkward, but that's okay. So, we just have to make sure it's orthogonal, and we do that by comparing V3. So, V3, ipahiga ko na siya agad just so we save some time. Pero effectively, I'm just transposing it. So now let's add them. So C1 times 0 plus C2 times 0 is just 0. C1 times 1, so C1 plus C2 times 3, 3C2. And then C1 times 3, so 3C1 plus 8C2 equals 0. Okay. So, what this implies is, considering na we're talking about spanning the space, so meaning, most of the time, or in the overwhelming majority of the times, C1, C2 are not 0. So these are assumed to be non-zero for the sake of finding the solution. What that therefore means is na, if these are non-zero, then V32 and V33 have to be both 0 for the dot product to be 0. Right? Kasi if this is assumed to be non-zero, then these two have to be 0 para 0 yung dot product mo. So now we have more information, and it's mostly about which ones are 0, but that's okay. Okay. So that's the next piece of information. This is basically the span of those vectors. We took the kailangan orthogonal siya, so dot product 0. So ayan, more info. We're slowly narrowing down what the vectors are. Next naman, let's take info F. V1 dot V3 is equal to 0. So let's take na lang what we have so far. So V1 dot V3 is equal to 0. So ipahiga ko na yung, I'll transpose V1 na for the sake of saving time. V1 1 0 V3 V1 3 times 0 0, and then this is V3 1 equal to 0. So this gives us two pieces of information. So una, V11 and V13, we're not necessarily sure about whether or not they're 0, but we know na one of them is. So we don't have information on here ulit kasi it's just multiplied by 0. But now we know na it's either V11 or V31 that will be equal to 0. So let's just keep this in the back of our minds while we try to look for more information. So moving on to G naman. We know na V2, the magnitude of V2 is equal to 1. So this is same lang as, I think this is math 22. So V2 is equal to 1. This means na given our V2 is V21 0 V22, that just means na V21 squared plus, skip na natin yung middle, V23 squared is equal to 1. We can't really go from there muna. Pero we know that this information exists na, so we can just get back to it later. Yung more useful though is yung sa H. Kasi what it tells us is na the magnitude of V3 is also equal to 1. Ibig sabihin yan na V31 0 0 supposedly yung magnitude yun equal to 1. So we have V3 1 squared, and since 0 yung iba, wala na yan, equal to 1. The square cancelling the square root, V3 1 is equal to 1. So there, goods na tayo dun. Is equal to 1. So, that means now we have completed V3. Oops. Wait lang. Yan. So now, goods na tayo with V3. We found V3. We can go back to F. From F. Remember na, we set this property. We had this piece of information. Because alam natin na V31 na yung 1, it suggests na this cannot be 0. Therefore, this is 0. V11 is 0. You can also add that to what we know. Okay. So now, we move on to I. I basically says na the projection of L onto V1 is 0, 10, 5. So, and it also tells us, let's use J na rin, na L is the span of V2. So, going back to the span ulit. So, let's first find the span of V2. So, the span of V2, given that we have this, is, let's just look back at yung info natin for V2. Which is ito. Given that we don't know what these are, it's a bit hard to directly find the span. Pero, it's fair to assume na it is likely that this will it is likely that this will be like it'll likely span these two vectors. So let's assume muna na these are non-zero. It's kind of a risk, pero we have to do that para we move forward with the solution. So yeah, we're gonna take that risk para we can try to extrapolate some info. And then if there's a contradiction, edi we go back to the drawing board. But let's assume muna. So this means that the span of V2 is 0 AB. We don't know what A and B are yet, but we know that this is the span. It'll span basically a 2D space. So now that we have that, now that we have L, now we can substitute it back to V1. Oops, sorry. Now we can substitute it back to V1, which is ito so far. So, recall na lang na the projection from 22. I honestly don't know if they'll ask like this degree, pero we want to make sure lang. So, the projection of A onto B is equal to A dot B over of B onto A is A dot B times the magnitude of A squared times A. Yeah, so let's just apply that to here. So we'll take the dot product of, so basically this will just become L, and then this will just become V1. So dot L, and then L squared, then times L. Okay, so V1 dot V2. So ayan, let's just put 0 A B. V1 pala, sorry. V1, oops. V1 0 0 0 0 unknown, let's just put C since we used A and B na. 0 A B dot product niyan. Since L is V2 and we know na magnitude of V2 is 1. This is just the magnitude of L squared, which is just equal to 1 squared, equal to 1. So, wala na yan. And then all of that, so we'll get a number here. We'll get a scalar quantity multiplied by L. So 0, A, B. Yan. Okay, so we can do direct dot product. You can just technically do this, like multiply nyo lang siya dyan sa corresponding. It will yield the same value as transposing it. So now, we get na magka-cancel yan, yung lalabas lang is BC. So BC is now a scalar quantity. We can now multiply that scalar quantity with the vector 0, A, B. And yung sabi dito, it should yield the vector 0, 10, 15. Yan. So, to move to the next page. So we can now relate them. So what we can do is multiply lang. So magiging A, B, C is equal to 10. So taking this, tapos pwede namang along dito. B squared C is equal to 5 lang pala. 10, 5, not 15. 5. Yan. We can do some manipulation. We want both sides to be equal para we can equate them and get some information. So we can write them both in terms of BC. So BC is equal to 10 over A, and then BC is equal to 5 over B. This will make sense later. So then 10 over A is equal to 5 over B. Just multiply them both onto the numerator. 10B is equal to 5A, which gives us the information na 5 na A, A is equal to 2B. So now there's a relationship between the both of them. Recall ulit, this is V2. And we know na V2's magnitude is 1. So we can reuse the information we got from G. So, recalling G, na we can, so this is V, so we'll use A and B na lang para madali. So A squared plus B squared is equal to 1. We know na 2B is equal to A. So we can just turn A into B. 2B squared plus B squared equals 1, which gives us 4B squared plus B squared equals 1, which gives us 5B squared equals 1. Separating, ilabas yung B, square root of 5B equals 1. And therefore, B is equal to 1 over square root of 5. And since 2B is equal to A, we also know na A is equal to 2B is equal to 2 over square root of 5. Yan. So now, we have information for V2. So, V2, we know na B is 1 over square root of 5, 2 over square root of 5. Yan. Okay. So, the last thing we can do now is revisit dito. The last thing we'll find is C. Recall na my relationship na tayo for what C is just this. So we can use either. I'll just use ABC is equal to 10. So, revisiting F ulit. No to. I forgot na. J pala. I to J. Revisiting I to J. We get na ABC is equal to 10, which therefore means 2 square root of 5 times 1 square root of 5 times C is equal to 10. This means that 2 over 5 times C is equal to 10. 25 is equal to C. So now we have the last element of V1. So ayan, nahanap na natin lahat. What we can do now, just as a final check, is to run through the conditions again and make sure they all satisfy. So let's go. At A naman, again, anything satisfies this because x1, x2, and x3 are 0, so this gives us no information. V1 times E2 or J hat lang nga is 0. So quick check, 0, 1, 0. Get the dot product. Yep, 0 siya. So we are safe there. V2 times the image of B is 0. The image of B is 0 nga is along X lang. So it's a line up along the X axis. So we can like just 1, 0, 0. Okay. Yep, check siya. We are good there. V is orthogonal to the span of the following vectors. So actually just kahit di nyo nasundin yung rule on basis, just like manually plug in every single one. 0 siya lagi because the second and third elements mag-0. Yung first element is 0, so yung 1 laging maka-cancel out. So whatever you plug in there between the 3, mag-0 yan when you dot product. So that's good. V1 dot V3 is 0, so 0 times 1, 0 times 0, 0 times 0, 25 times 0. Yep, tama. And then, this one is the one we just solved recently, so it's a bit long. Na-verify na natin na tama yan. L is in the, puts na din yan. And then last, all elements of K are non-negative, which is true. So, goods na tayo. Almost. Obviously, they will penalize us if we don't give what is initially asked, which is matrix A. So, the last step is just to put it together. Wait, ba't ko ginagawa dito? Yan. Yan. Okay, so just put it together na. 0, 0, 25, 0, 1, square root of 5, 2, 5, 1, 0, 0. Yan, that's the final answer. Okay. Oh, okay. So those are the two biggest problems on this samplex. Before we proceed to the next section, I think it would be good to just take a quick breather. Goods na ba tayo? Any questions? Anything that you'd prefer we re-explain? Feel free talaga because gets naman, this is very long. I think si Dandy yung gumawa nito, like when he was there. So, yeah, very tough question. I'm not sure. Pero yeah. Are we all good? Can I get a confirmation? A verbal one kasi I cannot see the chat. Hello? Hello? Okay. Sige. We can continue. Okay, do you guys prefer we take a break or diretso na sa short items? This time I actually need your guys' input. Hello? Okay. I can now see the messenger chat, so you guys can also just message there if you guys prefer diretso na or we take a break, like a 5-minute break. Okay, thank you. So any is fine daw. Thank you, Jay. Sige. I think break na lang. Yeah. Somebody messaged me then directly in a break. Okay, sige, let's take a break. Let's be back 8:40. If you're on stream, you can just I guess chill na lang din. If you're watching the replay, skip 5 minutes forward. Wala kaming gagawin the next 5 minutes. Okay, to save time, I'll just write down all the setup I need na for later. Pero ayan, okay. 8:40. Let's go. Okay. So let's now do some of the parts sa other questions. Again, I'll try to make it as much as possible na since people have class pa tomorrow and wala pang linear transformations. I'll do that last. Okay, so let's do part 1, number 1. So consider two linear transformations, a rotation and a reflection. The sequence of application of these transformations on an arbitrary vector has no effect on the resulting vector. Okay, I said I wouldn't, pero this one is straightforward kasi. basically, malalaman nyo bukas na linear transformations are basically just matrices. And they convert a vector into another vector. And you can do that with spaces as well. Without delving much into it, all we have to know is na because you treat them, or because they are represented as matrices, you have to treat them with the same properties that matrices have. And the most important for this question is na matrices are non-commutative. So since matrices are non-commutative and linear transformations are treated as matrices, this is false because they are not commutative. The order by which you apply the linear transformations or by which you multiply vectors does matter. So the answer here is false. Okay. Number 4, diagonalization. Diagonalization of a matrix yields another matrix with the same eigenvalues as the original matrix. By definition, recalling lang what you did in number 1, for this to be true, you needed first, you needed these two to have the same eigenvectors and eigenvalues. Sorry. That's why, diba, nagumana to na trick. And we could do exponentiation much easier. So by definition, in order for matrix exponentiation, the technique to work, we needed diagonalization. We needed their eigenvalues to be the same. So this is true by definition. Okay, so now let's move on to problem solving. So let's do number 1. Let's do number 4. Sorry. Determine the values of constants a, b, c, d, e, f, and g such that the set of vectors are orthonormal. Additionally, restrict the values of a and c to be non-negative. So again, let's just do the same thing we did dati. And store all the information on the side para it's easier to reference. So we have 3 matrices: A, D, F, B1G, and CE 1/2. The first piece of information we have is na orthonormal yung hinihingi. And orthonormal is just basically orthogonal, but they also have to be normalized. Hence, orthonormal. Ibig yan sabihin is the magnitude is always 1. So, yan. So, just writing that down. Okay. The first thing na I want you guys to observe is na from this pa lang, may makukuha na tayo na info, which is, notice the second one. If we bring this down here, notice na may 1 na. And given na square roots, diba, cannot be negative. This implies na the only possible values really for B and G, and when we can actually just remove the square root, square both sides. B squared plus 1 squared, which is 1, plus G plus 1, G squared. Yan. So mag-cancel yan. B squared plus G squared equal to 0. And because, so, ibig sabihin lang yan is, B and G have to be 0. Kasi, diba, isi-square mo siya, meaning the values are always positive. So even if you redistribute it to be like B and then negative G squared, it's impossible by contradiction if it's anything other than 0. Kasi the lowest possible number of this value is 0. And ito naman, the highest possible number of this value is 0. Kasi if it's G, like G equals 1, negative 1 squared magiging 1. I mean negative 1 kasi you square first before adding 1. So basically, ibig lang yan sabihin is B and G are both 0. So there. May information na tayo. Okay. Let's see if we can get any other information. Now that we have a bit more, we can now start to see which one is they have to be all orthonormal to each other. So they also have to be orthogonal. So because nakompleto na natin yung second vector, we can now try to multiply it. Try natin, kailangan may lumabas na 0, diba? So let's start with these two vectors. A, D, F dot 0, 1, 0 is equal to 0. Kasi orthogonal. Again, sige, i-transpose ko na lang para convention. A, D, F 0, 1, 0. Okay, so again, no information sa A and F for the same reasons as before, but we know D has to be equal to 0. So that's another piece of info. Yan. Okay. So let's move on muna since we can't do any more between the two. Ito naman. Let's multiply 0, 1, 0 C, E, 1/2. Okay. So same thing here. We don't have any information sa C. Sa E though, meron. E times 1 is E. Has to be equal to 0. So now we also know this is 0. We've already tried between all of them, diba? So we'll have to go back to the drawing board, find another way to gain information. Observe though na nahanap na natin yung 2 out of 3 vectors sa third vector. So now we can go back to yung definition na it has to be normalized. So bringing this back here, we can now do C squared plus 0 squared. So wala na, plus 1/2 squared is equal to 1. Again, remove the square root by squaring both sides. C squared plus 1/2 squared, let's just do that 1/4 equals 1. So lipat 3/4. Therefore, C is equal to square root of 3 over 2. Yan. So may info na tayo on C. So we've completed the third vector. Square root of over 2. Yan. So now, the only one we haven't tried is itong dalawa. So now we can do that to gain the final bit of information. A 0 F dot square root of 3 over 2 0. Let me recheck if this is sensible. Okay. Okay. So now we have square root of 3 over 2a plus f over 2, okay, f times 1/2 equals 0. So we can relate these two. So square root of 3 over 2a equals negative f over 2. Cancel the 2's. Square root of 3a equals negative f. So now, while this isn't, the most useful yet, magagamit natin to. Kasi this is a relationship in terms of each other. So now we can plug this back in here. Kasi nahanap na natin yung value of d. So 0 na to. So we're effectively left with one variable if we relate f in terms of a. So that's what we will do. Or actually just a in terms of f in terms of a. So just move this around. Yeah. Okay. So now we can bring this back. A squared plus 0 squared because d is 0. And then negative 3 square root of 3 a squared equal to 0. So, equal to 1, sorry. Square both sides. A squared plus, then we just square it now. 3a squared equal to 1. 4a squared is equal to 1. A squared is equal to 1/4. Therefore, a is equal to 1/2. Yan. So, we now have a, and more crucially, wait, I'll have to make it smaller again. Sorry. Oh, yeah. Yeah, okay. So, a is equal to 1/2, and we have a relationship for what f is in terms of a. So, negative square root of 3 over 2 times 1/2 is equal to f. Sorry, negative 3 times 1/2 is equal to f. Negative square root of 3 times 1/2 is equal to f. Therefore, yan. That's f. So, putting that all together, I'll bring this down. Putting this all together, the values are 1/2, 0, negative 3 square root of 2, 0, 1, 0, square root of 3 over 2, 0, 1/2. Let's just remember na may condition na sinat out sa simula, which is A and C need to be non-negative. So let's just recheck that. A is this, correct, non-negative. And then C is, which is C nga? C is, ayan, first vector of the third column, first element of the third vector. Okay, tama. So these are negative, these are positive. Wait. Okay, tama pala. Positive yan. Yeah, C is positive. This is not a negative symbol. Yan. Okay, so tama. We have fulfilled the conditions then. So that's basically the final answer. Pero you can just list it down then to be extra sure na A equals this, B equals this, C equals this. Kasi, malaki yung kaltas from not following instructions, as I have learned today. Okay, whatever. So, last, before we move on to linear transformations with the extra time, let's do 5 and 6. So 5 and 6 is just straightforward. Find the eigenvector and then the eigenvalue. So this is rudimentary na. So no extra like mental gymnastics. Alright, so okay, wag ko na nga i-shortcut. 5, 4, 1, 2 minus identity matrix times lambda. So lambda 1, 1, 0, 0. But then again, this is just equal to, oops, sorry. Is equal to just having lambdas across like, oh my god. Sorry, my pen is not the original one. So it's bugging out kasi medyo mainit na. Okay. So then this just becomes 5 minus lambda 4 minus 5 minus lambda 4 1 and then 2 minus lambda equal to 0. The determinant of that. The whole determinant is equal to 0. So let's just get the determinant of this, and that can be done by since 2 by 2 siya, diagonal method na lang since it's the easiest. 5 minus lambda 2 minus lambda times 2 minus lambda minus 4 times 1. Alright. So then that gives us 10 minus 7 lambda plus lambda squared minus 4 equals 0. And then that gives us rearranging everything in the form we are familiar with. Lambda squared minus 7 lambda plus 6 equal to 0, which gives us, if we factor this out, lambda minus 6, and lambda minus 1. Tama ba? Negative 6 minus 1, 7. Okay, correct. So, ayan. It's in factored form, and it's easy to see na lambda is either 6 or 1. Sorry, na ano lang ako. Smallest to biggest. No need naman. Personal preference lang. Yan. Okay, so those are the two lambdas. So now we can plug them in as per usual. So for lambda equals 1, let's just reuse this. 5 minus 1, 4. So 4, 4, 1, 1 times x1, x2 equal to 0. 0 vector. Dapat. I'm not sure how much they will be strict with this, but let's just practice good habits na rin. So, just to practice good habits ulit, let's make this row echelon. Although it's very obvious na kung ano yung sagot dito. Pero let's just practice good habits. Row 2 prime equal row 2 minus row 1, 1/4. To eliminate this, this will become 4, 4, 0, 0. And then that's what we can plug back into here. So yeah, technically walang nangyari, pero in some items may nangyari. So that leaves us with 4x1 plus 4x2 equals 0. And therefore, 4x1 is equal to negative 4x2. It gives us the relationship x1 equals negative x2. So, we can do the thing we did at the very start. Let x sub 1 equal to k, part of the set of real numbers. Therefore, the eigenspace is given by k times 1. And then just remember the relationship, negative 1. X1 is equal to negative x2. Yan. Because, yeah, negative siya of the other. So, that's the eigenvector corresponding. Yeah. So, goods. We're also just following here. Solve systems following reduced row echelon form. Set any arbitrary constants equal to 1. Which is what we have been doing anyway. Because it's generally good habits lang din. It's just also personal preference. Mas malinis siya. Anyway, enough waffling. We can move to the next one. For lambda equals 6. We get... Oh, I think... Wait, I'll preemptively move. Yeah. For lambda equals 6, we have 5 minus x, so negative 1, 4, 1, and then 2 minus lambda, so negative 4. Yun. X sub 1, x sub 2. So again, I think it's a bit apparent na dito ano yung itsura ng sagot. But let's just follow the instructions. R2 prime is equal to R2 plus R1. Eliminates this, allows us to get reduced row echelon. Oh, and then let's just do R1 prime equals conventions. Negative 1 times R1. Yan. So, doing that, let's do this first. So, magiging 0 lang to. Magiging 0. And then, 1, negative 4, x1, x2 equals the 0 vector. Yan. And then, x1 minus 4x2 is equal to 0. Move it around. X sub 1 is equal to 4x2. In this case, let's let x2 naman be equal to k para wala tayong fractions, pangit yung fractions. Same shabang we did. And then, yan. 1, and since x1 is 4, x2, yung 4 yan. So this is the eigenspace. Hinihingi lang dito is eigenvector. So, we just remove the k. So, bali ito yung vectors natin. 1, negative 1, and 4, 1. So the eigenvalues are 1 and 6. The eigenvectors are 1, negative 1, and 4, 1. Ayan. So that is it for the common questions. Sige, if you're under Sir Nesty, I think some people kasi, I don't think this will be beneficial na if I discuss pa yung linear transformations. But for Sir Pierre sections na tapos na, it is beneficial. So, someone from Academ, could you guys just release the feedback form na ngayon? And again, since attending a review session is an involvement task, you have to submit the feedback form to get your attendance taken. Sina Gwen are starting to count attendance na. So, someone from Academ, please send the feedback form. I'll discuss pa rin linear transformation questions. Pero I do understand if it's not beneficial na to people who haven't even had it in class yet. Okay, so ayun lang. If you have to leave, thank you. For the rest of us, let's do number 1 since yung linear transformation. So let's do this. Matrix X is rotated 90 degrees counterclockwise to get matrix Y. So X rotate 90 degrees to get matrix Y. And then matrix Y is flipped across to get matrix Z across x-axis to get matrix Z. And then Z is equal to negative 2. So my initial value tayo, renotate siya 90 degrees. And then we got matrix Y. Yung matrix Y, flinip natin siya. And then we got Z. And then Z is negative 2, negative 2. So, recalling lang from the class kanina, we can represent linear transformations as matrices. So, ibig lang yan sabihin, may hinahanap tayo na weird missing value. Tapos, missing matrix. Tapos, minultiply natin siya with matrix X. So, this is the transformation. This is X. Nag-result siya in negative 2, negative 2. So, yung challenge dito is, hanapin natin yung transformation para mahanap natin yung X. So, this one requires a bit of visualization. I rechecked yung slides natin. This required a bit of outside research. But I honestly think baka ganito pa rin yung lalabas sa exam based on last year. So, let's first imagine what it means to rotate 90 degrees. Hindi ko pala sinulat. 90 degrees counterclockwise. So, recall na if we want to get the attitude of an entire matrix kapag tina-transform siya, we just have to look at the attitude of its basis. So, in R2, kasi this is two-dimensional lang, diba? In R2, remember na the most basic basis for to span R2 is our parang unit vectors, diba? From physics. So, J hat pala to. J hat and then I hat. Just so we're more familiar, this is practically just the matrix 0, 1, and this is practically just the matrix 1, 0. Makes sense, diba? If this is the x component, 0 yung x component niya, 1 yung y component niya. Sa I hat naman, 1 yung x component niya, 0 yung y component niya. Okay. So, i-rotate daw natin siya ng 90 degrees. So, yung itsura niyan is hindi siya perfectly perpendicular. Okay. So, yung bago nating values, bago nating itsura ng is this 0, 1? Ito na yung I hat, 'di ba? Parang renotate natin siya. Tapos yung J hat naman nandito na. Because they're unit 1 lang and they're still straight. alam natin na yung i-hat natin naging oh wait, bro. Yan, yung i-hat natin naging 0, 1 siya. So from 1, 0, naging 0, 1 siya. Tapos yung j-hat natin, from 0, 1, naging negative 1, 0 siya. Make sense, no? Kasi this is now negative 1, 0. This is now 0, 1. Yung parang coordinates niya. So yeah, matrix coordinates. Somewhat interchangeable. So, let's first get the transformation that will give us this result. So let's first start with i hat. So something times 1, 0 will give us 0, 1. So ano kaya yun? First, let's determine the size. This is 2 by 1. This is 2 by 1. So therefore, this has to be, yung katabi niya, this has to be 2 para compatible sila, diba? And then, to get the outside, we want this to be 2 as well. So 2 by 2 siya. 2 by 2 siya. Tapos, now let's think about ano yung kailangan natin ipasok na value. Sige, for this kasi, yung first row, 0. So, wala tayong idea. Diba? But we know for a fact na kailangan 1 yung sa baba. So, alam natin na this has to multiply with something dito such that 1 yung lalabas. So, we know for a fact na this is 1. But we don't know what this is yet. And that's okay. Yan na lang muna. Tapos sa taas pala, we know na this is yung dito has to be 0 kasi may 1 dito, diba? And it multiplies with the element here. So for this to be 0, this has to be 0. So may information din pala dito. Ay bad. Yan. So 0, 1. This is still unknown. Kasi the way we get the second part naman is to then multiply it with j hat or with the second this vector. So now naman 0, 1, yung kalalabasan niya daw is negative 1, 0. So, let's revisit. Yan. Okay. 0, 1 times dito, lalabas daw negative 1. So, because 0 na yung dalawang element, nakalock na yan, at 0 talaga yung product nila no matter what. Dito yung magbabago. This has to be negative 1 para when you multiply this to this, negative 1 lalabas. Same thing here. This multiplying with this, kailangan to siya na 0 kasi mag-multiply siya with 1, diba? So, in order for it to be 0, kailangan niyang maging 0 dito. So, ayan. Na-complete na natin. And now we know na rotating 90 degrees counterclockwise is actually just this matrix. Which is consistent with actually, like, this is actually an objective fact. Like, this is a property. I don't know why di nila tinuro, considering na this might be important in the exam. So like, parang, yeah. Search na lang sa Google or something. Oh, I'm starting to sound like, anyway, yan. So, nakuha na natin yung first part. Pero remember, from when we did true or false, di ba nagmamatter yung order? So, yung transformation na to, hindi lang yan ito. May ginawa din tayong something else. Para apparently mag-flip siya along the z-axis to get z. So, we have to get that as well. So now, given na sequential nga siya, we use the most recent state, or this one. We bring this down, yan. Ito naman, flip down natin along the x-axis to get matrix Z. So, ano itsura niyan? Yung itsura niyan is, flip natin. I'll use another color for clarity. Ginamit ko na pala yung dark blue. Wait, sorry. Yan. Hindi naman. Yan. Okay. So, ito, yung xj hat natin na nasa negative 1, 0 na. Sorry. Ito, this vector, na-flip siya. Ito yung na-flip. Ito, unchanged. So now, this is still negative 1, 0. And ito naman, this is now 0, negative 1. Makes sense naman, di ba? Kasi, flip mo lang siya along the x-axis. So, along this axis. So, ES1 moment. Ito yung parang line of reflection or whatever. Sorry. Hindi ko na maalala. So, we do the same thing here. Hanapin natin yung kailangan na matrix para ma-transform to. So, again, let's just leave this blank and then leave this blank. Pero alam natin this is 2 by 1. Alam din natin na this is negative 2, negative 2. Yun yung given. So, this is 2 by 1 din. So, same thing. Check natin. So, this has to be yung second, parang yung number of columns niya has to be 2 for it to be compatible, di ba? And then, we check the outer lang. This 1, tama. And then, this has to be 2. So, 2 by 2 siya ulit. And then, let's do it 1 by 1 ulit. Let's first start with the matrix na nagbago. Just because we'll get more info out of it. So, let's now do, wait. Sorry, hindi pa pala ito. Hindi siya negative 2, 2. Yung finished state siya. So, this is 0, negative 1. So, ito, sinalpak natin dito. Tapos ito, isasalpak natin dito. Okay? So, this is now 0, 1, yielding 0, negative 1. Let's test again. Let's test again. Tapos, so let's multiply. Okay, so ito, multiplied dito. It has to be 0. So this implies na the element here has to be 0 kasi you're multiplying it with 1. So it has to be 1 times 0 para maging 0, diba? You have to zero out this number. So 0 na yan. Same thing here. We're multiplying this with 1. So kailangan, because this is 0, and you know whatever will, so, wait, let me just make that super clear this time. 0 to, i-multiply siya dito. Whatever number shows up, 0 siya. So kailangan, these two elements, when you multiply together, end up with negative 1. The way to do that is to make sure this is negative 1, para, since eto and eto, whatever number this is 0, but this will be negative 1, so you get negative 1. So, that is solid. That is complete. Now, this is still unknown. So, let's move on to the next vector, which is yung di nagbago. Negative 1, 0 became negative 1, 0. So, 0, negative 1. Okay, now let's multiply. Negative 1 and 0 multiplied here. We want negative 1 to be multiplied with something such that negative 1 yung lalabas. That is just 1. And then, next naman is to multiply 0 or to multiply this with this. And kailangan 0 yung lalabas. This is good na. 0 times negative 1 is 0. So now it has to be negative 1 times something equals 0. And to achieve that, this has to be 0. So then, yung mangyayari is you will end up with this. So, alam na natin na this is the linear transformation that converts this to this. So, this is the linear transformation of the entire thing na. Which means that wait, sorry, just verifying. Actually, so now you have two, diba? So this is the first transformation, this is the second transformation. You want to multiply them kasi you're taking the overall transformation. So those two transformations have a factor in the overall transformation. So you have to multiply them. And remember, the order matters. So right to left tayo. So take the second, lagay mo dyan. And then lagay mo dito. And take the first, ilagay mo dito. So, 1, 0. So the overall transformation, the one that we were not sure about, ends up being, so multiplying this, you get 0, -1, -1. Wait, I'm checking lang. -1 and 0. Yan. Okay. So this is the overall transformation. So now, we can plug this thing back into here. We can plug this thing back into here. So, yung vector, yung initial matrix X natin, is transform siya through this. So, 0, -1, -1, 0, times matrix X, we just let it be X1 and X2, equal to -2, -2. Yan. So then, let's just do that individually. So multiplying this by this gives us -x2 is equal to -2. And then multiplying this by this gives us... Actually, let's do this in formal matrix form. So this just basically becomes this times this. So magiging -x2, and then this times this, magiging -x1, -2, -2. Solving for this, we get na x2 is equal to 2, x1 is equal to 1. Therefore, your original matrix, x1 is equal to 2 then. So therefore, your original matrix is 2, 2. Yan. And you can, if you did the graphical method, which it says please do not use. Pero kasi we're just counter-checking naman. So as long as we actually did it mathematically, I think it should be fine. If you think about it, 2, 2 is somewhere around here now. 2, 2 is somewhere around here. We rotated it 90 degrees. So it's now somewhere around here. Right? And then flip natin siya. Makes sense na -2, -2 is somewhere around here. So from eye test, mukhang tama naman. So, goods. Yeah. So, we're also just counter-checking if tama. And as per the answer key, tama naman. So, that is it for number 1. Ayan. So, I hope that makes sense. Go ahead. If
Hi,
somebody's...
Sean. Sorry. For
Go
the
lang.
flip, because like when I first read the word flip, I was like, oh, it's probably like 180 degrees. Is there like a word na if ever not the flip, if like the question was like rotate 180 degrees, is there like a word for that? So I don't get confused.
I think it will just say rotated 180 degrees. Kasi flipped across the x-axis. Gets ba? Na parang hindi mo rin na-rotate yung... Kasi we're talking matrices, right? So this is like a space. So this is technically like a space of vectors. And then lahat sila renotate mo. Well, they're all from the origin, pero yeah. As opposed to a flip where they are parang ninenegate mo lang yung y value nila.
Oh, okay,
So,
not gonna lie, it's Math 22's fault. I think like the graphing like changed my mindset. I'm fixing it now. Thank you.
that's okay. By the way, the reason why I think I have a grasp of it is if you guys have seen yung playlist ni 3 Blue 1 Brown on the essence of linear algebra, super useful. I watched that before the start of the sem, and I mean, pumapasa naman ako, so I guess that's something. So far. Ayan. So, ayun. That's for the long problems. Since we have 10 minutes, I'll do one more short problem. And then let's just see. Okay, so part let's do part 1, number 3. Because this will also be quite important. So an arbitrary transformation that results in the vector x to x plus y is a linear transformation. So how do we verify when something is a linear transformation? Same thing lang. In the same way na we confirm na a vector space is a vector space, or a space is a vector space, by ensuring two things. One is closure in two forms. So closure in two forms. Closure under scalar multiplication, and then closure in addition. So we will test for both. Let's first start with scalar multiplication, just because it's a bit more straightforward. Basically, I think you guys have seen this notation in class. Yeah. So a transformation converts all vectors u into a specific vector v. So one-to-one yan na conversion. We can rewrite this as t, arbitrary lang to, ab. And that should give us, apparently, xy lang pala, sorry, xy. And that should convert it into x to x plus y. So that's effectively what the problem is asking for. Now let's check if scalar multiplication works. And in this case, you can just use 2, multiplying it by 2. So if scalar multiplication is true, if may closure siya under scalar multiplication, edi dapat yung t 2x times 2y is equal to 2txy. So, kung totoo na may scalar multiplication yung linear transformation, it has to follow na pwede mong ilabas yung parang multiplication. Okay, so let's do that. Ano yung magiging ano nito? So basically, we take this as inputs on the left, and these are the outputs on the right. So since x magiging x lang, yung first element magiging x lang daw, that's just 2x. And then 2x plus y, meaning we take 2 of this, and then we take 2 of this. Yeah, that makes sense. So yeah, 2x plus y. Yeah. And then, sorry. Tama. Right. 2x plus y. Okay. I know, we did ano pala. We did multiply by 2. So this becomes 4x plus 2y. Apologies. And then, we can do 2 times the transformation here. So, sabi dito, xy just becomes x times 2x minus y. So that just becomes, so ayun nga, transformation siya. So nagiging x 2x plus y. So nagiging ganito. Multiplying on the right side, 2x 4x plus 2y. Okay. So mukha namang, yan, exactly equal sila. So therefore, my closure under scalar multiplication. Therefore, it follows, this implies na closure under scalar multiplication. Goods. Okay. Lastly, let's check if there is addition. For addition naman, we will have to use arbitrary numbers. So let's transform A and B. If this is true na transformation, it follows na if you add inside, A plus C na lang. A plus C, B plus D. This is equal to the transformation if you added them instead of added them outside instead of inside. What this looks like is, just give me a bit. If you transform yung through the inside naman, AB plus C D. Yan. So let's do that. So first ito, sabi yung x magiging x lang. So magiging a plus c lang ito. Pero yung baba magiging 2x plus y. So this is x, 2a plus c plus y, which is b plus d. Yan. So then, this equal 2, just doing it individually. So ito naman, transformation neto. Oops, sorry. Transformation ng a plus b. So magiging a to, because that's your x component. And then your y component becomes 2x plus y. So this becomes 2a plus b plus this is c and d. So same thing, c and then 2c plus d. Let's check. Simplify both sides. A plus c, 2a plus 2c plus b plus d. Yan. And then that is equal to a plus c, 2a plus b plus 2c plus d. Let's check. So a plus c, tama. 2a plus 2c plus b plus d. Check. So therefore, this is closed under vector addition. So therefore, since they are both closed under since closed under both sila, therefore it is a linear transformation. Yeah. Okay. So, yun. It's 9:28 na. So we'll cut it off there. I hope this makes sense. If you have any questions, ask them now. Or you can just PM me or PM anyone from Acad Engagements. Yes, we will upload this to the folder then. And yes, for the solutions, for the items na hindi na-cover, there are answer keys naman. So, again, please answer the feedback form, especially if you are a mem, because this is how we will count your involvement task. If you're an app naman, I guess this is like a short little welcome to how we take our ACADs here in IE Club. I hope you guys learned something. Good luck in your app process and everything. And yeah, that's it from me. I think we will have to do documentation as far as I know. So please help us secure our KPIs. Wait, I'll stop streaming. Okay. Game. Do we just turn on cam or someone from Acadeng? What do we do?
Screenshot na lang.
Sige.
Do we turn on our cam? Can you guys turn on your cam? Okay. Are we still on stream though? Sorry. Yeah.
Yan.
Okay. Habol kayo. 1, 2, 3. Ayun, may humabol. Wait lang, loading. Ayun. 1, 2, 3, smile. Okay. We're good. Thank you so much.
Okay, thank you guys. Good luck next Tuesday.